Hello and welcome back to CS33 Introduction to Data Structures and Algorithms Part 2. We are now on our fourth video, and this video is for our greedy algorithm solution for the coding problem. So what is the coding problem? Coding is an assignment of bit strings to alphabet characters. So one example of a coding problem is how can we represent the readable alphabets from A to Z or 0 to 9 to something that we can represent in a computer memory using zeros and ones lang. So how can we represent each character uniquely? That's a coding problem. And then another example of a coding problem is how can we transmit messages using Morse codes? So we can have another representation na hindi naman binary but dots and dashes if we will use the Morse code. So the code word here is the bit string assigned for each character of the alphabet. So for example, A has a binary representation, S has a binary representation, and the binary representation here is the code word. So for each character symbol, meron tayong tinatawag na code word, and what we wanted to do in the coding problem is to identify what is the code word for a particular alphabet. So there are two types of codes. The first one is if we allow fixed length encoding, just like what we are using in the current implementation of ASCII codes. So at the moment we are using 7-bit representation for each character. So for A, let's say may specific 7-bit code word na ginagamit in the memory to represent A and so on. And as well as numbers, for example, we also use code words to represent that, and we used certain types of encoding. So another type of code is hindi na fixed, which is a variable length encoding. So one example of a variable length encoding is the Morse code. So the idea for the Morse code and for variable length encoding is that dapat mas maikli yung code word mo or yung representation mo for characters that are frequently used. For example, character E, the most common in the English language, and character A has a shorter sequence of Morse code representation. I guess it's the dot and the dot dash representation for E and A respectively for the Morse code. And for the infrequent letters, we can use a longer encoding. So we want to have as much as possible a short message when we are trying to deliver a hidden message. The second type of code imposes a problem. Ang problem is, since we have a variable length encoding, pag binabasa na natin yung encoded value of the message, we don't know when to say that this particular substring is still part of the first character or part na siya ng second character and so on. So, nagkaroon ng tinatawag na prefix-free code. So, no code words is a prefix of another code word. So, our goal for the coding problem is to provide a variable length encoding that is prefix-free. The coding problem is if we know the frequency of the character occurrences, what is the best binary prefix-free code? So, for the English language, of course, the frequency of A's and E are different. Compare it to Tagalog or any other languages. So, for each language, of course, yung frequency of the character changes. So, there is an appropriate code word that can minimize the total length kapag nag-encode tayo ng message. The coding problem has a greedy solution, and it's called the Halfmans algorithm that uses the concept of a Halfman code. So a Halfman code can be represented using a binary tree with edge labels. So kapag it's a left edge, it is labeled as 0. Kapag nasa right, it's labeled as 1. So, and then the leaf of the binary tree are the character symbol that we are trying to represent. So, to read what the corresponding code word for symbol A, B, and C, we just need to traverse the binary tree from the root to the leaf. So for example, we can say that the representation of A here is 0, 0. Representation of B is 0, 1, 1. Representation of C is 1. So if we use this type of representation, hindi laging fixed length yung code word for each symbol. And also, we can guarantee na walang common prefix or prefix-free yung set of code words natin. So the goal of the coding problem and the greedy algorithm for the coding problem is to produce the optimal binary tree that minimizes the average length of a code word that can be constructed using the Halfman code. So our objective function here is the average length of a code word. Later on, we can explain more about this objective function. So the way how we do it for the Halfman's algorithm is number one, to initialize n one-node trees with alphabet characters and the three weights with their frequency. So kumbaga parang you can represent each symbol as a node with their corresponding frequency. So for example, in the text, ang frequency of the character B is 0.1. The space here is parang 0.15. So, I guess in this case, hindi total number of occurrences of the symbol yung ginamit, but the probability. So, or the percentage of the space, percentage of B. So, this is equivalent to 10%. This is equivalent to 15%. This is 20, and so on. So, parang ganun yung way of assigning the frequencies. Initially, you have a forest with single nodes each. What we wanted to do is to create an optimal binary tree that can encode the symbols. So the goal is for us to have this as the leaf of the tree. So what we can do is to sort these nodes according to an increasing frequency. So least frequent, then more frequent. Okay? And then what's next is to combine the least two nodes and create an internal node with the internal node as the sum of the frequencies. So for the first iteration, we have this, and for the second iteration, we can have one internal node for BN space with the total frequency of 0.1 plus 0.15, so that's 0.25. Okay, so we can see here in this example that we can have an internal node 0.25 with B and space here as the children, and we also have individual nodes separated. So the next step is again arrange this to an increasing order and then combine the node with the least frequency. So in this case we have C and D. So if we combine these two, we can have 0.4 na internal node. And then using that 0.4 as the internal node, we sort it again. So if we can have the new internal node 0.4, if we try to rearrange this and compare the total frequency, we can have 3, 0.25, 0.35, and 0.4. Since we have 0.25 and 0.35 to be the least two subtrees of this forest, then we need to combine this both. And combining this both, we can have 0.25 plus 0.35 as an internal node, and that is equivalent to 0.6. Okay. So since we have this, we need to sort it again. So we can have two choices na lang. That's 0.4 and 0.6. If we combine this, we can have 1. So finally, we have one binary tree where the leaf of the tree are these initial set of nodes. So what we need to do is to label the edges, 0 for left subtree and 1 for the right subtree. And we do that for all the edges of the final tree. So what we can do now is to interpret this binary tree using our definition of the Huffman code a while ago. So to represent C, we need 0 and 0. Okay. To represent D, we can use 0 and 1. So we have 0, 1 here. For B, we have 1, 0, 0. Okay, this one. And for the space, we have 1, 0, 1. Okay. 101, and then for A we have 11. So as you can see, the character symbols that are more frequent, sila yung mga nasa mas mataas na level ng tree. And with representation na lesser yung number of bits na nagamit. But for less frequent symbols like B and the space, medyo mas nasa mababang part sila ng tree. And again, this is a code word with a variable length and prefix free din yung code word. So, walang single representation dito na substring. Totally parang substring ng isa sa mga existing code words natin. Okay? So, let's try to compute yung average bits per character. And this is computed by getting the length of the representation or the code word times the frequency of the symbol. So we get the summation of that. We can have 2.25. So 2.25 is computed by getting the 0.35 times the length of the code word for A, which is 2. We have 0.1 times 3, which is the length of the code word for B, and so on. So we can have 2.25 as the average bits per character. So if we will use a fixed length representation for this, we need at least 3 bits for the symbols. So if we use 3 bits, ano ba yung natipid natin? So we can get a score which is called the compression ratio. So the compression ratio is the fixed length encoding minus yung average bits per character over the fixed length encoding times 100%. So ang sinasabi dito is that we can nakatipid tayo ng 25% of the memory compared with fixed length if we use the variable length representation. Okay, so